Hello everyone, today we are going to calculate how much energy can be saved from anaerobic digestion compared with activated sludge. Saved means that energy recovered from in the form of biogas or biomethane, and also that can be saved from avoiding the aerobic treatment. Before actually we had this kind of mass balance around anaerobic digestion, and if we have 100 kilogram of COD going through the anaerobic digestion, you could expect something like 40 to 45 cubic meter of methane of biogas containing 70% methane, and effluent containing 10 to 20 kilogram of non-biodegradable, or maybe something like COD still actually not converted to methane, and also sludge something like 5 to 10 kilogram per 100 kilogram of COD. So in this case, the energy saving and or energy gaining, basically, it's actually composed of two amounts. The first amount is biochemical energy in the form of methane, basically come from the organic pollutant that is converted to this methane, and this pollutant actually expressed as COD or volatile solids, and this can represent about 12.4 megajoule per kilogram of COD. Besides that, actually, this energy savings in anaerobic digestion, something like 1.8 to 3.6 megajoule kilogram recall per COD treated. Adding this together can actually 14 to 16 megajoule per kilogram of COD treated. This slide actually taken from Professor Jean Vallier from TU Delft. And here an example actually how to use this information to calculate how much energy can be produced from anaerobic digestion. And if you have a food processing company produces wastewater containing 10 kilogram of COD per day, 10 ton means that actually this can be obtained by uh, the flow rate of wastewater and the concentration of COD in this wastewater. And assuming a high rate anaerobic digestion with a treatment efficiency of 85%, what is the total income from electricity generated from biogas if a combined heat power generator is used to generate electricity from biogas, assuming that the electricity price is 15 cent per kilowatt hour. So if we have actually this kind of small Excel sheet, so we have actually here the daily COD production, 10 ton per day, and energy production from each ton of COD is about 12.4 gigajoule per ton of COD. This also can be actually obtained by knowing the calorific value of methane and the theoretical methane production per kilogram of COD that we had before, 0.35 liter per kilo per gram of COD. And the treatment efficiency again is 85%. This is known from the example description. And we have this combined heat efficiency of 40%. And the specific electricity saving from aeration, if we don't have to use aeration, of course, in anaerobic digestion, basically this about, yeah, taking 1 kilowatt per kilogram of COD, and the electricity price is again 150 dollar per megawatt hour, or basically 15 cent per kilowatt hour. And electricity generation, this is just a conversion of 3 gigajoule per megawatt hour. This is basically the theoretical actual conversion between gigajoule and the megawatt hour. Sorry. And in this case, actually, we can actually calculate the total daily energy production. This theoretical, basically this B2 times B3, basically B2 times B3 give you how much gigajoule per day, and actual means that you need actually to multiply this theoretical one per times uh, the efficiency of CO of the process itself. So basically 85% is converted to methane, and the rest is actually ending up in the effluent. And again, so in this case also you have electricity generation is 11.7 megawatt hour, based on the multiplication of the amount of energy produced divided by the conversion of basically between the electricity generation and the heat. And again, using also the efficiency of conversion of biogas to electricity, which is 40%. From that, you can actually total energy saving from avoiding aeration, assuming that 1 kilowatt hour per kilogram of COD removed. So basically, you can expect this kind of 8 point megawatt hour per day. This assuming again 80% is converted to methane. In this case, is avoided if you don't have to use to use aeration. So total energy saving will be basically B13 plus B12. So basically the energy generated from electricity and the energy saving from aeration, and adding this together times the price of each megawatt hour, which is in this case $150 per megawatt hour. This basically give you the total income per day. And if you multiply this by 365 days, you can actually get the annual income, which will be about 1.1 million dollar per year. Again, this is just an income. This is just actually doesn't include any operational cost or basically the capital cost for each of this system. So with that, I would like to thank you, and I hope actually this is useful for you. This is just again, I would like actually to just stress here. This is channel is not really actually something to challenge anyone. It's just to actually teach actually people who doesn't know or people who don't know this kind of basics. Again, it's not really to have somebody actually coming and make philosophical argument, or maybe actually showing that this is actually simple for him and he come to put a comment or whatever. I don't care basically if you are actually putting a comment or not, if you are subscribed or not. This is just actually something I do to teach other people who may be interested. Thank you. Bye bye.